Well, welcome to exploring OpenUSD this week, and we've got a lot to talk about. I just got back from GTC a little over a week ago, and it was amazing. So we'll talk about that a little bit today. Unfortunately, Jen couldn't make it, and Edmar is taking some much-deserved time off. So here we are, and let's see as people roll in. Please send me a message. I want to hear from you, and I'm actually going to pop over. We have viewers from X, and we love you over there. We can't send messages directly back from our StreamYard platform yet, and so I'm going to pop over there, and when we send messages back, I'll just post them to X directly myself. So because we definitely want to have a discussion with you all. All right. So let's just start by talking just giving a recap of some of the things we saw at GTC. And I really want to hear your questions. And if you were there, I want to hear your thoughts and what you saw. And then we're also, let's start there, okay? So if you were in our live stream yesterday, there were something like 20,000 people at I'm not sure, somewhere between like 15 and 20,000 people at GTC. There were a few 100,000 attending virtually. I mean, and then even at the keynote, we actually the keynote was in a hockey stadium. And just the week before I came out, I went to a Journey concert with my wife, and it was just completely sold out. And the keynote was the same way. So the energy at GTC was through the roof. I met so many amazing people, and there were a lot of announcements. Especially, we've been talking about robotics here quite a bit, and there were a lot of exciting announcements about robotics. One of my favorites is this Groot project that NVIDIA Research has been working on. And they're working on these foundation AI models for robots. And the concept is, if you're training a robot, you can start with one of these foundation models that will run different robots pretty well from the start. And it's just generally good at training itself and learning. And I think it's going to be a real game changer, because right now, training a robot, you have to start from scratch, and it's just a lot of work. I'm sure there are some models you can base from, so you probably don't have to model or go completely from scratch, but suffice to say, it's a whole lot of work. So let's see here. Let's see. Just need to check real quick. Yep, there we go. All right, so let's see. Let me show all of you. Before I get started, Edmar usually does this, but I just want to share with you our calendar of live streams, just so that if you are interested, if you like what you see here, so you can subscribe, join us every time. I'm just getting you that link right here. I got it. Usually Edmar here helps out with this stuff. I'll post it on Twitter, on X as well. Let's see here. Yeah, so that's our link. If you want to check out more live streams, if you want to see what's going on, hop over to Add Event, and that lets you add the live stream schedule to your calendar. It's really handy. But let's talk about, so my main activity at GTC this year was I hosted a hands-on DLI lab where we taught an autonomous race car to drive itself. And I'll just actually share the result of that. Here we go. So here I've got NVIDIA Omniverse running on my Linux laptop. And what I can do here is I can load this scene. Here we go. And the car you see here, we developed from CAD. It's built off of this car right here. I'll make this one big. So here I've got an F-110 autonomous race car. And I measured this and I modeled up a template in CAD. And then we imported that CAD into Omniverse, and I showed how to do this. There's a tutorial that what we shared in this DLI lab, and I will be publishing that open source as soon as it goes through all of our internal checks. That's in process right now, and you can just take that. You can import that from CAD into Omniverse. And that includes its joints and everything. Onshape is great for that. The Onshape importer is our first importer, CAD importer that will import not just the geometry, but also joint definitions. So it's a little bit easier to rig up robots if you can import those joints. It's easier to rig those joints in CAD than in Omniverse right now. And so it's nice to rig those in CAD and then be able to import them. And then, so you import that, and then you can use USD layers. You can use USD layers to I've made this auto rigging workflow so that you can use my same layers even if you change the dimensions of the template and re-import that CAD. And great question from Zia. What do the internal checks for the DLI consist of? Well, we start with legal checks, like we need to have a license, a proper open source license for the repository. That license has to be compatible with any assets we share. It has to pass security checks. We just want to make sure we're not releasing any kind of malicious code or code that we don't have code or assets that we don't have the rights to distribute, that sort of thing. All important stuff. So so here we have, and in this tutorial, it'll show you where to get that template. It'll show you how the layers work that automatically rig the template, and then it'll have you build this scene. Then I've got this extension. I've got to enable it. Window extensions. Come on. Here we go. Then it shares the source code for this extension. So with this extension, if I click capture, it captures the current viewport. And if I click on it, it saves that click location to that image on disk. And what that does is you can drive around the track with using a ROS node that it's also published in the repository. So you can drive around this track with that ROS node, and you can capture and click as you go. That builds a data set. And if you drive around for maybe 20 or 30 minutes and do that, you can capture 400 or so images, which is enough to train a model to, in that model, you train an AI model with that right here, actually. Let me make this window bigger. If I click on this train button, it didn't work for me this time, but this laptop doesn't have enough VRAM to train the models, but you need like a little bit. This has got an A3000. You'd want, which is equivalent to like a 3060. I think you'd want more like a 3070 or 3080 at least to be able to run this simulation and train simultaneously. That said, you can train with this extension. You can train the model, and then you can even evaluate it. And that model, what it does is it takes the image that you pass it, and it tries to predict where on that image you would click. It's just really a simple AI model. And so it tries to predict that. And if I click evaluate, it'll just do random positions right now, just pretty much random, because the model is just essentially a blank model. But you can see that green dot is trying to predict kind of from the viewport where would Eric click. And you can load and save previous models you've worked on. And anyway, you can use this extension to train a model to drive this car around the track. Really slick. And let's see. What else? So you can drive it with the keyboard using a ROS node. You can capture images and build a data set. You can use that data set to train a model. And then we have another ROS node that will look for images being published from Isaac Sim. It will pass those images through this model, and then it will process those click positions into steering angles and throttles and actually drive the car. And I'll show that now, actually. And that is, I actually publish. This is all in this open source repository. This whole workflow, and in the repository, there's a pre-trained model that I trained that works. And so you can, if you just want to drive the car around and play with it, you can just do that part. I mean, it's really fun. But let's open up my terminal. So we start a simulation running here. And then if we go to CD source, CD, just kind of going to the right, to the location of the ROS nodes. Then we'll run one. We'll run the one that drives the car now. There we go. And there it goes. So the car is driving itself off of this model that's just predicting where would Eric click. And then what we do is, based on the position, you can see my mouse. Let's say it predicts here. Then I calculate the angle between the straight forward direction and that line. Great question from Zia. So it calculates that angle and then trains the steering angle. And great question from Zia. If you move the cones on the track, do you need to retrain from scratch? You absolutely do with this one. And yeah, you absolutely do. And let's see. And also if you change the background. So right now, this one only works with this blue grid background that comes with kind of with Isaac Sim. Now, if you were to, I took a LiDAR scan of a gym and brought that in, and we just tried it to see if it would work. And you could tell that it was trying to steer. It couldn't quite figure it out, but you could really tell that it wasn't just like starting from zero. And in fact, let's say that you had a data set with these cones. Rather than start from zero with your data set, you might be able to just add 100 or 200 images with your new track and add those to your data set and then retrain on that new data set. And you might have a model that works on either track, right? And that's kind of, so that's the direction we're headed. And so this is a DLI course that we ran at GTC, and I will be releasing that open source. I don't think I'm going to make it. I'm going on a trip for the next 2 weeks, and I don't think I'll make it before that trip. It's just taking a little bit, it's just a little slower than I anticipated, but not to worry. I will be releasing that. It's very important to me. And let's see. And I might even do a video where I basically do the DLI class as a video and just to show people how things work. Let me stop this. But with that, let's talk about like where are we going next, you know? I'm going to shut this one down because I think we're done showing that off. So let me just remove this one. And let's just do some thinking and planning together. I've just got a little drawing app here. Sure, let's just create a little canvas right here. And I just want to talk about a few of the things we want to cover, right? I want a circle tool here. So we want to be tied in with NVIDIA research. NVIDIA AI. Like if you go to LinkedIn and follow NVIDIA AI, that's who I'm talking about. And just give us no fill. And what they talked about are this concept of agents. Okay, this is like Eureka and Groot. Let's just give a quick overview of how agents work. And I'm going to, let's see. Groot is not published yet, but Groot is based off of Eureka. And so let me share, I'm going to share a blog post here about Eureka. And Zia is asking if I can release a rough version. It's actually not about the quality at this point of the materials. It's about going through those security and legal compliance inspections. So I can't release until I've been through those inspections. Yeah, and what we might do. Yeah, so there you go. So I've released. Let's see, we've got once I release it open source. I think what we can do is a special live stream where we go through it in an hour and just go through the live tutorial, just like we did. I'll just kind of go through it piece by piece. Okay, so if you look at this Eureka robotics research, and it's actually related to Jim Fan's Mind Dojo paper. Let me find that one real quick. Here we go. Here's another blog post I'm going to share with you all. Giving you homework today. So there's the Mind Dojo blog post, and the papers are all on the archive, so you can read them yourself if you'd like. So Mind Dojo, and these are basically generally capable agents. So for example, Mind Dojo, it used video tutorials. He trained an AI off of video tutorials of Minecraft, and also Reddit posts and blog posts about Minecraft, which there's a huge body. There are a huge body of, Minecraft tutorials and instructions and things. So he trained an AI on that, and then he cut it loose in Minecraft and let it play, and it could actually play pretty well. And there are other papers on that after that made it that off of Mind Dojo that made the agents play even better in Minecraft, but they could even do tasks that they'd never done before and pretty well. And it's really amazing what these agents can do. And yeah, and you can talk to it using like a Chat GPT or an LLM and ask it to do things, build me a modern looking house, and it will do pretty well. And then the Eureka paper, kind of parallel to that, it uses the Eureka model. It uses reinforcement learning, and one of the biggest challenges with reinforcement learning is to write the reward system for the reinforcement learning to teach, because if you're not familiar with these learning methods, what I've got here in this DLI lab that I shared is called supervised learning, right? I drive the car around the track, and I have to be present, and I'm building that data set by hand. And I've got some slick automation that it kind of automatically annotates it, or it makes it easy to annotate the images, is more accurate. But still, I have to be present, and I'm training it. With unsupervised learning would be any machine learning method where you do not have to be present. And reinforcement learning in particular is where you have some kind of a simulation in a physics or simulation environment like Omniverse, and then you just have a reward system that tells the robot if it did, or the AI if it did well or if it did poorly. And you optimize based on that reward system. Usually that's going to have to be a non-gradient optimization method, such as a genetic algorithm. I think, well, it's usually a genetic algorithm. That seems to be the most common from what I've read. And so you'll essentially just kind of optimize that neural network using just a whole bunch of simulations and let it teach itself. Eureka, what it does is you would tell ChatGPT, and they use GPT-3, I believe, even, or 3 and 4. They use both, but you use ChatGPT to tell Eureka, or to ask it to write you a reward function based on what you want to do, and Eureka writes the reward function, and then it uses an additional genetic algorithm to optimize those reward functions. So it's actually generating the reward functions based on your prompt. And it works. It actually can generate better reward functions than people can. And it can even do I think it can do some zero-shot tasks. I've been reading a lot of papers, and so I get some of them a little mixed up. But you can ask it to do things, and it'll generate those reward functions, and then you can train it, and it works really well. So, and then Groot is built off of that. The difference with Groot is that it's from the videos I'm seeing, they're humanoid robots, but they're also training them in Isaac Sim. So this idea of agents, right? That's really going to be an important part of reinforcement learning. So, well, and to Zia's point here, humans not assigning rewards is fantastic. It's actually, and you actually assign the reward, right? You just say what you want it to do or what the reward is, but at a high level, right? Using human language. And then ChatGPT writes the reward function code. And that code doesn't always work at first, the first time it generates it, but there's a system built into it that will kind of iterate on that code until it's functioning code. It's really cool. So these agents are really an important part of the reinforcement learning space, which is, I think, where we're interested in reinforcement learning in this live stream. So that's one piece of the puzzle for us, okay? Okay, another piece of the puzzle. I was going to say API. This is another really big, important GTC announcement, okay? And that is that Omniverse is headed in the direction of cloud APIs. And what that means is, up until now, if you wanted to write an Omniverse, if you wanted to work with Omniverse, you had to come to the Omniverse ecosystem, right? Whatever you wanted to do, you had to write an Omniverse extension for it that would work in the Omniverse platform. You had to write your own custom Omniverse app. You had to write your own Omniverse microservice or content provider, and there's nothing, and you had to come to Omniverse. And one thing that we noticed with a lot of our developers and tool makers, we noticed that a lot of them already had an application, or they already had some other ecosystem where they were working, and it was a lot to ask them to completely rewrite their app or rewrite what they were doing or their workflow or their pipeline in the Omniverse platform. And so what we're doing is we will be starting to release Omniverse APIs. And for example, we'll be releasing an API that, given a USD scene, you just make a web API call to a server. That server renders the USD scene and gives you back an image, gives you back the rendered scene. Yeah, it's RESTful. So here's the question. Someone says Java API. They're RESTful APIs. and there'll be it'll be RESTful and it'll be gRPC. So there'll be a few options. So I mean, protobuf is really cool. But basically, you make this API call from Java, from VBA, from I bet I could figure it out in Fortran or COBOL. I mean, those are silly examples, but I think a more clear example would be JavaScript, or if you want to embed Omniverse into a website, you'll be able to do that. If you want to use .NET, you can use .NET. I think if you want to make a RESTful API call, you just get an image back. And so if you can display an image in your language, if there's some there's some way of displaying an image, I mean, heck, you could probably I bet someone could figure out how to convert the image to ASCII and display it in a console, right? It's just web API. So we'll be rendering on the cloud, and you get back and put it in your app. It's going to be so flexible. I'm really excited about it. And let's see, does Omniverse support custom shaders, something like high-level shader language? And I don't think it does. And really, the way you work in Omniverse is at a higher level than that. So you don't have to draw triangles or polygons. You don't have to develop shaders. You just work in the space of geometry and materials. So you can take your geometry and you can convert that to OpenUSD, and then you just give Omniverse OpenUSD. It takes care of all of that rendering for you. And as far as the shaders go, you give it materials, and there's this material. There are material graphs, and you can do very sophisticated materials. But you give it material, and it gives you back. It gives you back rendered objects. But if you're looking for, if you're doing HLSL, if you're typically doing more of like an effect, like I don't know, like motion blur or something, that's in your camera settings. And so Omniverse, I think, is a lot more natural to work with than HLSL. Now, let's say you wanted to do a cartoon shader or something like that. I'm not sure. And my hunch is that you could do that somehow, but I don't know. I don't have an answer to that. And excuse me. So there you go. So we're really interested in these APIs, and they're not out yet. But I think we can talk about some API topics, like what is a web API, what is protobuf or gRPC. What else? There are a few APIs already out. Like we can, like we've got Avatar Cloud Engine is an API based, is an Omniverse API. Another one is there are non-Omniverse but NVIDIA APIs, such that we've got these NIMs. So if you're at GTC, let's add that as a circle. Okay, a NIM stands for NVIDIA Inference Model. And essentially what a NIM is are pre-trained AIs that are packaged into Docker containers in such a way that you can call them as web APIs. So think of like NVIDIA's NeMo, which it's our large language model that is carefully trained on data it's trained on compliant data, and it has good guardrails, and it's kind of an enterprise grade large language model. And I think they said that will be republished as a NIM. So you can basically grab this Docker container, set it up on a server, and then call it through Web API. And oh, here we go. Great question from Edvard. I see what he's maybe trying to do. What if you wanted to do something like rendering an ocean for surface vehicle simulation? I saw the Siemens Digital Twin demo. Okay, we can talk about a few things to unpack here. Is all that done using the default Omniverse material system? Okay, great questions. For those of you who haven't seen, first let's just talk about the Siemens Digital Twin demo. And I think, well, there was a demo that I ran, like a booth that I ran, and it may not, I think you're talking about the huge ship that has a few million, it's like 7 million like unique components and like 12.9 billion polygons that it was rendering. Is a Siemens Twin, and then another question about that. Is that demo available? The demo itself is not available. I believe there are the video. I think there are videos available. It's certainly in that tech teaser. Excuse me. And I'm not sure when. The thing about that one is, okay, we come back to this API difference, okay? Like I said before, before you had to come to the Omniverse ecosystem, right? And that was really tough for a lot of, not only did it mean a big migration, but it was tough. It was tough for some people's business model. For example, Siemens, they've got their product Team Center. That is not an open source product. It is something that they sell. And but it could definitely use this high quality rendering we have, right? Siemens Team Center, it's a database system that keeps track of all these millions of parts for things like this ship, and helps you keep track of the CAD parts, along with any of their metadata, such as who's going to manufacture it, what's it made out of, is the manufacturing, what's the lead time, how long does it take to manufacture, right? There are all these questions about it that you track with Siemens Team Center, and up until now, and by the way, I believe Team Center has both desktop and web-based applications or versions. And if you had the web-based version of Team Center, you're using some kind of a web-based 3D rendering tool if you wanted to preview those parts. And that's somewhat limited. I mean, you can do, I think that they've gotten very impressive results for what they were working with, but the rendering in Omniverse is really out of this world. And so if you were at GTC, we showed off this ship. Let me see if I can at least pull up a picture. Here we go. Yeah, so here's a YouTube video. I'll share this link in the chat. There it is on Twitter. And here it is to everyone else, to all y'all. So what this is going to let them do, by the way, this is the CEO of Siemens AG. I mean, I can't believe that he's involved, right? And I think that just tells you that they are all in. I mean, and here we go. Here's the real shipyard. And look at this thing. Oh, here we go. Look how many parts. And so to render that into a web-based PLM system is really hard. You either have to really simplify it, or you have to just not render the whole thing at once, right? Yeah, tracking inventory must be insane. It is not just inventory, but the whole supply chain, right? All these millions of parts take longer time to make. I mean, with making things this size, you can end up with steel shortages, where It gets down to how much steel can a country provide from their mines, and from their foundries and stuff. It's really a lot of tracking, and that's where Team Center excels, is in this tracking these really large engineering assemblies. And so if you want to look at this whole ship, that's really hard to do right now because there's 7 million parts and 12.9 billion polygons. Is absolutely massive. And this is basically a steady, it's an entire, this one is I believe it's a natural gas refinery that just floats on the ocean. It's huge. And so what they're going to do what they're doing in Team Center X is they're using the Omniverse APIs to use the Omniverse renderer to render this in Team Center X. So they're not switching over to Omniverse. They've taken the pieces of Omniverse that are helping them, and they're adding them to their app. It adds value to their app. And that's what the APIs are doing for us. And so back to this question. So this is the digital twin, and it's really, and digital twin is not, people are calling it that, but really it's Siemens adding Omniverse to Team Center X through these Omniverse APIs that are coming out. Okay, now your other question. So to do an ocean simulation, if you want to actually simulate this buoyancy, that would not be done with the default Omniverse material system. For that, you'd use Warp. And Warp are Python endpoints to run CUDA simulations inside of Omniverse. And you can simulate water that way. So great question. Let's see if we can just Google it. I'll post a link here. Let me see if I've got, yeah. You can do data generation, simulation, all kinds of cool stuff. In this case, they're using it to simulate the forces, the thrust of this quadcopter. You can sim whatever you can code. So Zia says, can we sim fire as well? You can sim whatever you can code. So, and yeah. So, man, this is really... Let me post a link to that Warp documentation, that Warp page. Yeah, so if we wanted to do reinforcement learning of a drone, I think we could start with Warp to add those physics to Omniverse. Great questions today. Okay, so we've got agents, we've got API, we've got NIM. Let's add a circle for Warp, honestly. Or I'm not gonna call it Warp. I'm gonna call it like a simulation. Because the idea here, out of the box, Omniverse really only has rigid body simulation, right? And so if we want to add, more physics, if we want to add, fluid mechanics or, buoyancy at a rough seas, or if we want to add some of those things, we'll want to kind of dig into simulation a bit of how do we simulate other modalities than rigid body mechanics. More great questions. How deep will the new APIs go? Can we access event streams, for example? Okay, this is where I have to be a little careful what I say, because I'm privy to internal information. Let me see. I'm gonna see if I can come up with a graphic that I can share or not. I think there's a graphic that's been released on that. Just seeing if we got the... Here we go. Okay, great. We don't have an image, but here it is in the blog post. So I'm not the one to make new announcements. There's a lot of really awesome stuff. But this is this announcement about the APIs. Hold on a second. I'll have to go back to X in a minute. And these are the first, initially, there'll be these 5 core APIs. So one is render. So you give it OpenUSD, it gives you back an image. There's USD write that lets you edit USD query. Let's see, lets you make, ask about a USD scene. USD notify gives you notifications, lets you track changes. So if a USD file changes, you can get those changes. And then Omniverse channel facilitates collaboration. So those 5 APIs are going to be the first out, and that's just where we're starting, right? This is the core of Omniverse. That's where we're starting, and I think there'll be more later. But those 5, I think you'll be able to do a lot. That's the starting point. So let me make sure I've answered your question. So how deep will the new APIs go? Can we access event streams, for example? And that's how deep we are at this point. And yeah. More questions about Warp. Is Warp for numerical simulation only, or can we use it as a replacement for the vertex shader? i.e. displacing. You can do, Warp does numerical simulation, but you can take those values back and do what you want. And I think I've seen some soft body simulation using Warp. So yeah, you can absolutely displace vertices of a mesh. Really great questions. Let me see. Well, the cool thing is, like, one thing is, I get comparisons like this often. We're not competing. We don't, like, you can use Gazebo and then incorporate, especially with these APIs coming out. You can use Gazebo and then just add Omniverse features to your pipeline, And so I hope you don't ever feel like it's like Omniverse or something. I hope you feel like it's Omniverse and. I'm going to use Omniverse and Gazebo. I'm going to use Omniverse and Unity. Whatever pipeline you've got, whatever application you've written, whatever your business model is, we just want to accelerate you, right? Oh, cool. Yeah, so here we go. There's a cloth sim using Warp. Thanks, Sia. That's great. Okay. Let me think here. And it just bears mentioning. So let me just talk about, so we had that robot working in that virtual environment that I showed you in that blue screen, right? I'll pop it back up. And here we have a synthetic environment, and it's great. The thing about it is that we can't transfer to the real world from this, right? We've trained a model in this fake world. It doesn't transfer to real world. So I think that, and I think just implicit in all of this is that our goal is to operate in the real world. I'm not even going to put a circle. It's more like our foundation is we want to train in the simulated world to deploy in the real world, right? Well, actually, I will put it as another one of these circles. I'm getting a lot of circles here. That's okay. Sim to real, right? But as part of that, if we want to go from where we are here and do sim to real, we need to up our synthetic data game here. We're using synthetic data in this blue area, but it's not good enough to transfer us to the real world. And so we're going to work on that too. So these are the topics. And so it's a lot, right? But I think if we want to kind of be pace with where all of this, where we want to pace with reinforcement learning and where it's headed, this is the stuff. We need agents. We want, because actually, I'm going to call these foundation models, or even just gear. I forget what gear stands for, but let me just look that up real quick. GEAR stands for Generalist Embodied Agent Research. Well, it is GEAR, but let's just say agent. I think that's easier to remember. So we want these generalized agents, right? So, great question. It's not irrelevant at all. Great question. Does IsaacSim support UAVs? And there's a demo on that page I shared before where they used the warp to simulate a drone. And then I've actually worked with Brigham Young University. Some students there have fixed wing mechanics or dynamics, or can be actually pretty straightforward. And they added fixed wing mechanics to Omniverse as an extension. So IsaacSim does not have UAV physics out of the box, but you can absolutely add it. And then yeah, fixed wing aerodynamics. Okay, great question. Okay, with the development of these Omniverse APIs, is the company shifting more towards the cloud? Therefore, does it make sense to start studying now for the creation of connectors like FlexSim, or is it better to focus on using these APIs? And I think that Omniverse is going to be on the cloud and it's going to be on desktop. For example, IsaacSim isn't going anywhere, right? It's a desktop application. But I do think, as we open up these cloud APIs, my hunch is that there will be more tool makers interested in these cloud APIs than the desktop application, just because of your reach. I mean, if you can just think of the the configurator sample. You can write a product configurator, and let me see if I can pull one of those up. Omniverse product configurator. Trying to get a cool video because Ashley's been live streaming on this. When was it? I got one here. Yeah, here's a good primer. I think I'll share that in the chat. And actually, I gotta pop it up. I haven't been posting to Twitter. I gotta go ahead and do that. Cool. Yeah, if you check out our the Omniverse YouTube channel and go to the live streams, you'll see that, yeah, Ashley demoed her configurator. And I want you just to imagine that you can write a product configurator that looks amazing. It renders your stuff with high fidelity materials with ray tracing. You don't have to generate a bajillion images of every configuration anymore. You can just set up a few variants, and then you can deploy that to a website. So it's visible on mobile, on tablet, on Windows, on Mac, on Linux, wherever. And I mean, you tell me where most of our Omniverse users are going to be as soon as that really starts to kick off. And it's clearly going to be Omniverse API. There will be more Omniverse API users by far than desktop users. And think of Teamcenter X. That's Omniverse API as well, right? And as soon as the Teamcenter X version comes out with the Omniverse renderer, there are millions of Teamcenter X users immediately. Yeah. Let's see. Will there be I'm guessing DLI training on Warp? I don't know. I wonder if there is already. Let's see. NVIDIA DLI Warp. Wonder if there is one. I don't know if there's a DLI course on Warp or what they have planned for that. Oh, here we go. I'm just looking at the catalog real quick to see if I can find one. I love the DLI courses. I'm so lucky. I get to take them for free. I love taking the DLI classes. Let's see. Here you go. See all. Oh, those are the GTC sessions. Just trying to find that catalog. Browse learning paths. Here we go. No. Oops. Because I feel like there might be one already. Yeah. Oh, here you go. Course catalog. Oh, they have a new course catalog. Let me share that. Let me see here. Yeah, no Warp course yet. So I would start off with the documentation in the forums. Okay, in one Isaac Sim tutorial, there was acknowledgement of some shortcomings in physics simulations, which I share. Are there plans for a better physics solution, or things are the way they are? The thing to remember is that Omniverse is a platform. And so absolutely, I mean, there's already better physics simulations coming out. I mean, ANSYS is starting to use Omniverse. And so, I mean, yeah, there's that. And then you've got Warp. You can write your own physics simulations. And so I think that in DUI 777, I think that if you can see, like any one of you, if you're interested in flight mechanics, aerodynamics, you can write a Warp drone physics microservice or extension, and you can sell that. It's not right. I mean, that's your business. You can sell that and make some money. That's what I hope you'll do. I hope you will be the developers of these tools. Now, Isaac Sim is a product, and we're always improving it, and that includes the physics. So I don't have a roadmap for that, but certainly it's improving. Let's see here. Okay, so let's go back to our chart. I don't know if I showed. So I've got agents we're interested in. And this is all around reinforcement learning. That's kind of our central hub. we need to get better at synthetic data. We want to use these APIs, and I just even in terms of synthetic data, I want you to hopefully see the vision of how useful these cloud rendering APIs are going to be. Is if we want to generate, so okay, it took 400 images to train a car to drive around a single static track. Now let's say we want to train it to drive in the real world. So the way we do that is we take that track, and instead of just training on images of the track, we train with random cones and random backgrounds. We add teddy bears and marbles and distractors to the background, and we generate a much larger data set with everything that we don't want the AI to learn randomized. Like, we don't want it to learn what a specific cone looks like. We just want it to learn that kind of cones are generally placed parallel to each other, kind of in these patterns. We want to recognize those patterns. We don't want it to recognize the background, so we randomize the background. And that's going to be orders of magnitude more images, maybe 10 times, maybe 100 times more images to train a model that doesn't recognize background or doesn't recognize a specific type of cone. And so if you have to render all those images, if let's say you have to render 10,000 images, you don't want to do that on your local machine and wait for it. You want to send that off to a render farm in parallel and have 10 GPUs all rendering images for you overnight. So let's see here. So yeah, we want to learn about these APIs. Absolutely. I think we want to learn how to call these NIMs, and for more than one reason. One reason is because we just want to use them. I just want to use these prepackaged inference models. But also, this is an example of a containerized API, and I don't know for sure, but my guess is that the architecture of these NIMs will be somewhat similar to the architecture of the Omniverse APIs. And so by learning these, that will give us a head start towards the Omniverse APIs. And this sim to real, we need to come up with synthetic data generation schemes and randomization schemes and domain randomization schemes and training schemes that let us cross that sim to real gap with complete confidence. And I want that to be, right now it's a bit intimidating and mystical. You might say, some people might say it's a dark art or a black box, or some of these phrases like that. I want it to be a completely open box, not intimidating at all, clear and easy to do. You're right. I don't think it should be. And domain randomization is the answer. I think there's some clear. I think we can come up with some clear methods to randomize our domain so that sim to real transfer is just no big deal anymore, right? It's just clear. We just want a clear playbook on this is how you do it, a tutorial even. And then finally, we want to add more to our simulations, right? We want to maybe add another domain. We want to do some of this stuff. Now, we can't do all this at once. I think I'll be gone for 2 weeks here, but I think the big announcement to me is this API announcement is huge. And to be frank, it's a little intimidating going from just direct Python to more of a web API method. So I think we're going to let's dig into that when I'm back here in 2 weeks. Let's start talking about these APIs and how to use APIs. We'll talk about containers and what they are and how they work and how those work with APIs, because that's where our multi-tenancy comes from. What I mean by that is that you can have more than one container using one GPU, right? So if you're going to do if you're going to do what Ashley's doing and embed an app into a web page, it would be expensive to fire up one GPU per instance out there. You want to fit as many people as possible onto each GPU, and so containers are the answer to that. So yeah, we've got some things to talk about, but I am curious for your input. So join us on Discord. Join us in the Jet Racer channel. That's kind of our reinforcement learning Ackermann robot channel. And join us there. I want to hear what you think and your opinions, because there's still some time to change direction. We want to talk about all of this. I think of it almost like an async, right? We got to do really great reinforcement learning. We've got to cover all these topics, and I'm okay doing one or another first, right? I'm excited about the APIs, so I want to start there, but I'm open to starting in a different direction first if you guys would like. So yeah, join us in Discord. I want to hear your thoughts, and with that, we'll end for today, and we'll see you in a few weeks. And I hope everyone enjoyed GTC, and we'll see y'all later.